This is a video from section 11.7 in a Calculus 2 class. Test the series for convergence or divergence. And with that, we are going to take a look at example 1. Suppose we have the summation from n equal 1 to infinity of, so this looks like n squared minus 1 divided by n cubed plus 1. Now, the question is, what does this series quote-unquote look like? Now, an equals n squared minus 1 divided by n cubed plus 1. B sub n is going to equal n squared over n cubed, which is 1 over n, right? Okay, now, I'm going to take the limit as n goes to infinity of an over bn. So this is the limit as n goes to infinity of n squared minus 1 divided by n cubed plus 1. And then I'm going to divide by 1 over n, but really that's multiplying by n over 1, which is the limit as n goes to infinity of, I'm going to get n cubed minus n divided by n to the third plus 1, which is 1, and that's positive. Now, what does that say? The summation from n equal 1 to infinity of 1 over n diverges. This is P series. And here I could say something like P equals 1, which is less than or equal to 1. Okay? Now, by the limit comparison test, what does that say about the original series? So I'm going to get the summation from n equal 1 to infinity of n squared minus 1 divided by n cubed plus 1 must also diverge. And that's, in a nutshell, how we do example 1. Let's take a look at example 2. Now, suppose we have the summation from n equal 1 to infinity of, we're going to go e to the n divided by n squared. Now, notice how the numerator is a power of n, but the denominator is not. So what I'm going to do is I'm going to apply the root test. Okay? So I'm going to look at the limit as n goes to infinity of the nth root of e to the n divided by n squared. But that's the limit as n goes to infinity of, now the nth root of e to the n is e. Now, if you don't mind, I don't have this in absolute value because you're summing up positive terms the whole time, right? And so this is going to be e over n to the 2 over n. So that's the limit as n goes to infinity of e divided by n to the 1 over n, but this whole thing is being squared. But that's e over 1 squared, which is bigger than 1. So the question is, what does that say about the original series? The original series diverges. by root test. That's how we do example 2. Now, let's take a look at example 3. Suppose I have the summation from n equal 1 to infinity of e to the 1 over n divided by n squared. So the question is, does that look like something I could integrate, right? So I'm going to let f of x be e to the 1 over x squared. So f is continuous and positive, excuse me, on 1 to infinity, right? To show f is decreasing. What is it that I do? Well, traditionally, what we got to do is take the derivative. So f prime of x, I'm going to take the bottom, I'm going to multiply by the derivative of the top, minus the top, times the derivative of the bottom. I'm going to divide by x to the 4th, x squared squared. So what I'm going to do is I'm going to factor out an e to the 1 over x. So f prime of x is e to the 1 over x times. Now notice how the x squareds cancel, right? And what I have left is negative 1 minus. And then it's 2x e to the 1 over x. I'm going to divide by x to the 4th. That's less than 0 on 1 to infinity. So that implies f is decreasing on 1 to infinity, and the integral test. So it's a process to show the conditions. The integral test applies, shall we say. Okay? Now, I'm going to take the integral from 1 to infinity of e to the 1 over x divided by x squared dx. Right off the get-go, this is the limit as L goes to infinity of the integral from 1 to L of e to the 1 over x divided by x squared dx. Right off the get. Okay? By a u substitution, right, we get the following. So this is the limit as L goes to infinity of, I'm going to get negative e to the 1 over x evaluated from 1 to L. Pop the L in. I get the limit as L goes to infinity of, I'm going to get negative e to the 1 over L minus negative e. That's just the same as plus e, right? But as L gets big, 1 over L is going to go to 0, right? Right here. So this is equal to e minus 1. So the integral from 1 to infinity of e to the 1 over x squared dx converges. And this is section 7.8 because it approaches a fixed value. So what does that say about the summation from n equal 1 to infinity of e to the 1 over n divided by n squared? This also converges by the integral test. Questions there? So this is example 3. I want to go ahead and take a look at example 4. So on example 4, we have the following. We have the summation. Okay, so we're going to do this one. So we're going to do the summation from n equal 1 to infinity of sine of 1 over n, like this. This is a classic limit comparison test. It looks exactly like 1 over n. So an is sine of 1 over n. Bn is 1 over n. Now, I'm going to look at the limit as n goes to infinity of an over bn. This is the limit as n goes to infinity of. So I'm going to get sine of 1 over n divided by 1 over n. So what I'm going to do is I'm going to let y equal 1 over n. As n goes to infinity, 1 over n goes to 0. So that implies y goes to 0. And so this is the limit as y goes to 0 of sine y divided by y. This is 1, and we showed this in Math 400. Okay? Now, and by the way, 1 is positive, right? Now, what does that say about the summation of the 1 over n's? This diverges by, you can say P series P equals 1, which is less than or equal to 1. And so what does that say about the original series? This also diverges by the limit comparison test. And that was example 4. The other one, by the way, was example 3. And we're going to take a look at example 5. I want to see if I can get a good 3 more examples after 5. Okay. Suppose I have the summation from n equal 1 to infinity of 5 to the n over 3 to the n plus 4 to the n. Okay. So we got to think about this a tiny bit, right? Now, 3 to the n plus 4 to the n. That's less than 4 to the n plus 4 to the n, which is equal to 2 times 4 to the n, right? So what I'm going to do is take the reciprocal. So 1 over 3 to the n plus 4 to the n. that's bigger than 1 over 2 times 4 to the n. Now remember, 5 to the n is positive for all values of n, right? So I'm going to multiply both sides by 5 to the n. And that's bigger than 5 to the n over 2 times 4 to the n. But this is 1/2 of 5/4 to the n. So it's really interesting, okay? Now, look carefully. So the summation from n equal 1 to infinity of 1/2 of 5/4 to the n, what do you know? This diverges by geometric series. So the question is, oh, and by the way, the absolute value of r is 5/4, and that's bigger than 1. So the question is, what does that say about the original series? So we get 5 to the n over 3 to the n plus 4 to the n. This also diverges by the direct comparison test. That's how that works. And that one was example 5. Let's take a look at example 6, perhaps. Okay, let's take a look at 6. Suppose I had the summation from n equal 1 to infinity of. Now, in the numerator, I get 1 times 3 times 5 times ... times 2n minus 1. In the denominator, I have 2 times 5 times 8 times ... times 3n minus 1. Okay. Now, what I'm going to do here is I'm going to apply what's called the ratio test. Okay? Now, I recognize it's not a factorial. That's fine. So 1 times 3 times 5 times ... times 2n minus 1 divided by 2 times 5 times 8 times ... times 3n minus 1. Okay. Now I'm going to do a sub n plus 1. So I'm going to go all the way up to 2n minus 1, and then I'm going to tack on the next term over. So in other words, I'm going to go 1 times 3 times 5 all the way to 2n minus 1 times 2n plus 2 minus 1 divided by 2 times 5 times 8 times 3n minus 1 times 3n plus 2, okay? All right, now, I'm going to take a look at the limit as n goes to infinity of the absolute value of an plus 1 divided by an. It's just ratio test. So I'm going to go 1 times 3 times 5 times. So I'm copying that down. Times 2n minus 1 times 2n plus 1, right? Divided by 2 times 5 times 8 times 3n minus 1 times 3n plus 2, okay? And then what I'm going to do is I'm going to take the reciprocal of that guy. So in other words, I'm going to go 2 times 5 times 3n minus 1. That's on top. On the bottom, I get 1 times 3 times 5 times 2n minus 1, like so. Now, watch carefully what happens, okay? The 2 times 5 times 8 all the way to 3n minus 1 is going to kill off the 2 times 5 times 8 all the way to 3n minus 1. The 1 times 3 times 5 all the way to 2n minus 1 cancels the 1 times 3 times 5 all the way to 2n minus 1. The question is, what do we have left? What we have left is equal to the limit as n goes to infinity of 2n plus 1 over 3n plus 2. But that's 2/3, and that's less than 1. Okay? So what does that say? That implies the summation from n equal 1 to infinity of. So I'm going to get 1 times 3 times 5 times 2n minus 1 divided by 2 times 5 times 8 times 3n minus 1. Converges by the ratio test. And that's how we do example 6. Now, let's take a look at example 7. Well, suppose suppose I have the summation from n equal 1 to infinity of the nth root of 2 minus 1 to the nth power. That's something raised to the nth power, right? It's a classic root test. And so I'm going to look at the limit as n goes to infinity of, and I'm going to get the nth root of the absolute value of the nth root of 2 minus 1 to the nth, like so. But this is the limit as n goes to infinity of the nth root of 2 minus 1, which is 1 minus, this is 1 minus 1, which is equal to 0, and that's less than 1. So this converges by the root test. And that's how we do example 7. Let's take a look. Okay, so let's take a look at example 8. Suppose we have the summation from n equal 1 to infinity of sine of 2n divided by 1 plus 2 to the n. This is a perfect comparison test. So I'm going to take a look at the absolute value of sine of 2n divided by 1 plus 2 to the n, right? Just the absolute value. If I make the denominator smaller, the fraction gets bigger, right? And this is greater than or equal to 0, by the way. Now, the numerator is bounded above by 1. The denominator, so let me back up. I can make that fraction less than or equal to 1 over 2 to the n. which is 1/2 raised to the n. Now, what do you know about the summation from n equal 1 to infinity of 1/2 to the n? This converges by geometric series. You can pick the root test, you can pick the ratio test. The only thing I ask is be right. So it converges by the geometric series test. Now, what does that say about the summation from n equal 1 to infinity of, where'd it go? I just lost it. Oh, here we go. The absolute value of sine of 2n divided by 1 plus 2 to the n. This converges by the comparison test. So, therefore, what do you know about the summation from n equal 1 to infinity of sine of 2n over 1 plus 2 to the n? This converges by theorem. All right, so that'll do it for this video for section 11.7, and we looked at 8 different examples. So, okay, thank you.